Hello, everyone. It's a pleasure to virtually meet you. My name is Bianca, and I am on the product advocate team here at Prefect. I hope you have been enjoying the summit thus far and are ready to dive into the topic of managing data lakes with Prefect. I hope the next bit of time that we have together shines a light on the ways that Prefect can clear up some of the chaos that can arise when maintaining a data lake. First thing we need to do is set the stage a little bit and talk about what a data lake is. At a high level, a data lake is a centralized repository for storing structured and unstructured data. Now, why do people use data lakes? What is the practicality behind them? Well, as we briefly touched upon in the previous slide, data lakes are great solutions for scalable storage, capable of handling vast amounts of data. They're also flexible and can be used to store semi-structured and unstructured data without needing to convert it into a fixed schema first. Data lakes support a wide variety of data formats, you name it, JSON, XML files, Parquet, Arvo, videos, images, etc. When it comes to the kind of content that can be stored in a data lake, this flexibility lends itself well to the schema on read pattern, as opposed to schema on write, which is typically common with utilizing data warehouses. So for schema on write, schema is defined and enforced when the data is written to the database. For schema on read, the schema is defined and applied only when the data is accessed or processed, which is a more adaptable approach for querying data that has different structures and comes from different sources. And beyond their flexibility, data lakes are often considered more cost-effective than traditional data solutions, especially for large volumes of data. Now that we have a grasp of the advantages that come with data lakes, what are they good for in a business context? They could be used for handling large-scale data analytics tasks that require significant compute and storage. Data lakes can also provide vast amounts of raw data necessary for training machine learning models and supporting experimentation with different algorithms and data processing techniques. And last but not least, they enable data scientists and analysts to explore and analyze data without the need of predefined schemas. And they support ad hoc querying and data discovery. Both of these points harken back to the schema on read pattern that we discussed in the previous slide. So far, we've discussed the benefits and applications of data lakes. Now let's talk a little bit about where the data actually lives. There are multiple storage solutions available for building and maintaining a data lake. Pictured here in this slide are a few storage solutions that are commonly used. At the end of the day, the choice of storage solution depends on various factors such as scalability, performance, cost, and integration with existing architecture, and of course, specific use cases. Now, I know in the first slide of the presentation, I had mentioned that data lakes are a centralized repository. However, the data within the data lake can be stratified into different layers. There is, for example, the raw data zone, which is the initial storage for raw, unprocessed data that comes from various sources. There's also a processed data layer, which is made up of data that has been cleaned, transformed, and enriched. This data undergoes data quality checks, deduplication, normalization, and other cleaning processes. Then there is curated data, which is highly processed and ready for analysis and reporting. Data from this layer has a known structure and purpose and has already gone through cleansing and transformation. In theory, this data could be loaded into a data warehouse for easy access. And last on the list is the application data zone, which is usually sourced from the curated data and enforced with any needed business logic. This data is readily accessible and usable for business intelligence, reporting, and application-specific needs. So far, we've spoken a lot about the contents of a data lake. However, it's important to keep in mind that data storage is just one part of the bigger picture. All of the components listed on this slide collectively ensure that a data lake can store vast amounts of diverse data for processing in an efficient and secure way. each component has a hand in keeping a data lake from becoming a data swamp, which is a topic we'll get to in a later slide. Now, while all of these components are important, we're going to shift our focus to data governance and orchestration. Governance is essential for measuring the performance of a data lake and making adjustments to the processes as necessary. This requires a system for monitoring and logging data lake operations. Orchestration is also a crucial component for managing the complex and dynamic workflows that collect, store, and process the data. Effective orchestration ensures that all of these processes work together seamlessly, efficiently, and reliably. To give you an idea of what these processes look like, let me go ahead and paint a picture for you. This slide lists some processes that benefit from orchestration and governance. I'm going to provide an example of each from the lens of Marvin Mart, a data-driven grocery store. First up, we have data ingestion. These are workflows that are responsible for ingesting data from various sources into the data lake. Think APIs, web scraping, images, social media, etc. Marvin Mart has regularly scheduled imports from their point of sale systems and loyalty programs, and also their IoT services. All of this information is stored in the raw data layer of their data lake and is kept up to date. Next, we have the flow of data between layers. If you recall from one of the previous slides, there are multiple layers inside of a data lake. Workflows in this category move data from the raw data layer through the other layers, from raw to processed, curated to application. Each advancement requires some level of data processing, whether that's ETL, ELT, annotation, cleansing, compression, etc. Marvin Mart has workflows for transforming, enriching, and cleansing daily sales data and customer satisfaction polls. Duplicate entries are removed, formatting is standardized, and data is grouped based on category. Then there's data analytics, which are made up of workflows and machine learning pipelines. Some of the workflows that Marvin Mart uses are for performing complex data analysis on their data lake. For example, running machine learning algorithms to predict customer churn or optimize inventory levels. Lastly, we have workflows that move data to applications and external systems. These could be databases or data warehouses like Databricks and Snowflake, or maybe even a BI tool like Tableau or Power BI. Marvin Mart wants to keep their stakeholders informed and up to date, so they have workflows that pass data from their application data layer into interactive dashboards for store managers, marketing teams, and supply chain managers too. To ensure that all of these operations are running smoothly and in a timely fashion, having good data governance and a solid orchestration framework makes a world of difference. This is where Prefect has a lot to offer. By empowering engineers to deploy, control, and observe their data pipelines, and ultimately, their data operations. So, why do people use Prefect to begin with? In a nutshell, Prefect ensures that Python workflows run in the right place under the right conditions at the right time. But the unfortunate truth is, oftentimes pipelines fail or break for a variety of reasons, from data issues to infrastructure issues. And Prefect offers a framework that makes it easier to let engineers know when failures happen and to help them recover quickly. Bringing it back to data lakes, with Prefect, engineers can implement best practices to keep their data lakes from curdling into data swamps. Data swamps are dark, dismal lakes that have become disorganized and difficult to navigate. Data swamps occur when data lakes lack proper governance, management, and curation, leading to a scenario where data is hard to find, trust, or even use. There's an absence of data governance, and data is low quality and difficult to retrieve. In the next few slides, we'll go over a few ways that engineers can leverage Prefect to escape entropy and establish best practices. For our first best practice, do leverage an orchestration layer to automate data lake processes to keep data fresh, clean, and accessible. Don't let data stagnate and become out of date or waste resources doing these processes manually. To enforce the previously mentioned best practice, engineers can build and automate resilient, scalable, and maintainable workflows for data lake operations with Prefect. This includes workflows for data ingestion, cleansing, and transformation. Automating these processes ensures that data is flowing through the data lake in a timely manner, resulting in more high-quality data becoming available for analysis. The need for manual intervention is also minimized, which saves a lot of time and resources. For our second best practice, do curate meaningful metadata that provides valuable information about the data in your data lake. Don't make it difficult to interpret or understand the content of your data lake effectively. To implement this best practice, Prefect makes it easy for engineers to track and monitor the objects that workflows produce and update over time all in one place. The feature that helps out the most with this is artifacts, which can be created directly within a Prefect flow or task and be surfaced in the UI in a nice human legible format. More specifically, artifacts can be used to publish data quality checks from in-progress tasks. This can help ensure that data quality is maintained throughout the lifespan of a pipeline. For the third best practice, choose a path for scaling workflows for all data lake operations. Don't let an increase in data volume result in your pipelines becoming inefficient or slow. Because Prefect is cloud agnostic, engineering teams can integrate and access their data lake seamlessly with Prefect workflows and scale using serverless container orchestration. This opens the door for scaling data lake operations that interact with cloud-based storage, databases, and other services as well. Now, I could go on and on about different best practices, but I wanted to include this fourth and final one for this presentation, and that is to use event-driven pipelines that are triggered in response to data lake events. Gone are the days of workflows sitting around just to babysit a data source by watching for new files and then triggering a downstream process. Workflows can now be triggered by events that are produced by the source of truth, which in this case is the data lake itself. With Prefect, engineering teams can be notified when changes occur in their data lake and automatically trigger workflows based off of these events. AWS S3 and other cloud storage solutions are great at emitting events when changes happen. Prefect, on the other hand, is great at ingesting these events and using them to kick off the right workflows at the right time. Now, triggering workflows based off of events sounds well and good, but how does the magic actually happen? On this slide, there is a list of Prefect features that interlock with each other to power flexible, event-driven pipelines. To see these components in action, our next stop is a quick demonstration, showing how these individual components come together. To give you some context, the project I'm about to show you was a labor of love by our sales engineering team. The project automates the ingestion and processing of near-Earth objects data from NASA's API into an AWS S3 data lake using Prefect for orchestration. It comprises two main components: a data fetcher that retrieves and stores near-Earth object data in S3, and a listener that processes the data upon arrival. All right, everyone, first things first, I wanted to start off in the repository where the AWS Data Lake project lives. Here is a lovely diagram which shows all of the moving parts in this project. It bears mentioning that the flows used for our data lake operations have been deployed using Prefect and are designed to run as ECS tasks inside of our private AWS environment. Our journey begins with a scheduled workflow that is represented here by our ingestion flow. Once this flow kicks off, it is going to send a request to the NASA Near-Earth Object web service to get the latest and greatest information about near-Earth objects, aka asteroids in our area. The flow is then going to write data to a JSON file and drop it in the S3 bucket inside of our data lake. This new file arriving in S3 matches the pattern used for our event bridge in AWS, prompting the event bridge to hit the unique endpoint of our Prefect Cloud Event webhook, which is the target. The input will also be transformed into a cloud event. Once the Prefect Cloud Event webhook is hit, it will then produce a unique event inside of the Prefect Cloud environment. This new event acts as the trigger for the Prefect automation that we've configured. Upon triggering, the automation action spins up a new instance of our event-driven transformation flow, which accepts the bucket name and object key as parameters so that it can read the new JSON file from the bucket and process the file and format it into a nice CSV. The final step is loading the CSV back into the S3 bucket. Now, if you wouldn't mind following me to the demo workspace, let's see what all of this looks like in practice. As you can see here, we have a lot of green happening in our workspace, which is always nice to see. Next, we're going to jump over to our deployments page and check out our ingestion flow deployment. One thing I want to take note of is that this deployment has a schedule tied to it. So every morning, a new ECS task is going to spin up to execute our 10 a.m. flow run. On the other hand, if you look at our deployment record for the transformation flow, which is responsible for cleaning and formatting our data, it does not have a schedule. What it has instead is a trigger. If we click on this link, it takes us to the automation responsible for kicking off new flow runs of this deployment. Here's where we've defined our custom trigger and our action. Upon further inspection, we can see what went into defining this custom trigger. Any event in our Prefect environment which matches this type of event from the following resource will cause the automation to fire. Down below, if we scroll down a bit, we have a little diagram showing the number of times this trigger has gone off. As for what's creating the events within our Prefect workspace, we have a Prefect Cloud Event webhook that is coupled with the event bridge we defined in AWS, the one that pings the webhook whenever a new JSON file becomes available. We chose Cloud Event as the template preset for our webhook to take advantage of its standardized format. As a result, the event in our Prefect Cloud environment is going to use the Cloud Event subject as the resource and the data attribute as the payload. Now that we've taken a look at the deployments, the automation, and the webhook, let's kick off a run of our ingestion flow. I'm not going to make all of us wait until 10 a.m., so let me go ahead and do a quick run of this deployment. As you can see here, we have a new flow run in our UI, which is executing as an ECS task inside of our cluster in AWS. Clicking on this takes us to the flow run page. As a quick recap of what this code is doing, it is responsible for grabbing data from the NASA Near Earth Object API, writing that information to a JSON file, and loading that file into our data lake's S3 bucket. I'm going to pop back into the UI so that we can check out the flow run page in a little bit more detail. Panning over to the Details tab, we can see some flow run metadata. Here we have some information about when the flow run was created and updated, and we can also see what or who created the flow run. In this case, it's my user, since I was responsible for clicking the quick run. Whoop. Here we have our flow run running. To finish my thought previously though, these records are always nice to have for traceability. So, once the ingestion flow is done, we know that there is a new JSON file full of asteroid data sitting in our data lake's S3 bucket, particularly in the raw data layer, if you will. If you recall what's supposed to happen afterward, this new file triggers our AWS event bridge, which pings our Prefect Cloud event webhook. The webhook then generates a new event in our Prefect Cloud environment, which in turn triggers our Prefect automation that kickstarts a new flow run of our transformation flow. Here is the new flow run of our transformation workflow. Upon further inspection of the details, we can see that this run wasn't created by a person or as the result of a schedule. Rather, it was created because of this event that triggered the automation in our Prefect Cloud environment. Since the flow run is done, we can click over here on our flow run event feed, and we can see all of the events that occurred during the lifespan of this particular flow run. Scrolling down a bit, we have the automation action that kicked off our transformation flow and the flow run events showing the various state changes of the flow and task runs. We also can see the block events capturing when the workflow read the raw data from the S3 bucket and uploaded the finished CSV. Each one of these events is something that an engineer could use as a trigger for another downstream process, or for even sending a notification. Clicking this Automate button takes us to a new page for creating a brand new automation. This brings us to the end of our demo. I appreciate you all for following along. Now, before I let you all go here, I do wanted to bring attention to one last best practice, and that is to use Prefect and don't miss out. Thanks so much for watching, and I'll catch you on the next one. Take care, everyone.